Welcome and thank you for joining us for another episode of the Husqvarna Water Connections webinar series. I'm your host, Richard Restucia, and we are back this year to start talking about something that is really important to every irrigation system, and that is your valves. And more importantly, we're going to be talking today about some of the messaging you get or alerts you get on your smart controllers that are letting you know you either have a valve issue or you may have a valve issue very shortly. And understanding the difference between those is really key. And Danny Martinez, our national sales training manager, who is out in the field every day with customers, helping them be better water managers, is going to take us through this webinar today. Now, for those of you who have seen Danny, you know what a great trainer he is. Danny's been in this industry for a long time. He's been a trainer with Irrigator Tech, did a great job with that. He is bilingual, really relates to crews very well. And the thing that I'm most impressed with Danny, and all those things are impressive, the thing I'm most impressed with is just his overall knowledge of irrigation and getting things to work properly. He's a wealth of information. I hope after this webinar, you'll take advantage of Danny and use him. Give him a call, email him, get some help from Danny, because he can really help your project be a nice turnaround. So anyway, Danny, welcome. Thanks for joining us today.
Sure. Thank you. Thanks for the kind words there. Appreciate being on and explain a little what these circuits alerts are and how they affect your irrigation system.
Yeah. So, Danny, before we get to that, I think maybe a good place to start would be, what does a valve do on an irrigation system and how does it work?
So your valve is kind of the gate that opens up the water to your sprinkler system. Your city provider provides water to your site, and then your irrigation controller electrically controls these sprinkler valves that allow each individual zone to irrigate your plant material.
Okay. And so it does that by sending electrical current, or how does it do that?
So your standard controller runs off a 24-volt system, and it'll activate a station, send voltage down a wire path to a solenoid electromagnet, opens up your valve, creating a pressure differential between the diaphragm, opening up and allowing the water through to your stations.
Yeah. So bottom line, Danny, if I'm not connected, if my wires aren't connected, or I've got a short circuit, and you're going to have to explain to me later what exactly a short circuit is, but if I've got that going on, then probably my water's not going to come on.
Yeah, electrically, when we're talking the wiring and solenoid in your valve, that's half the equation, the electrical component, and then we also have the hydraulic mechanical components what's inside the valve. What the electric current circuit is controlling, and we can cover valves on another webinar if we like to.
Yeah, I think we should. But getting the electric side down, boy, I've just run across so many water managers that want to have more information on this, want to learn how to troubleshoot in the field, want to understand what these alerts on their smart controllers are. So let's, why don't you take us through it?
Yeah, let's dive into the first one here, which would be an open circuit. So the simple way to kind of think of this is your controller turns on the light switch, right? You go, if you can see the fan above me out there has a little light. You go out there, turn the switch on. If that bulb was missing, nothing happens, right? Yeah, I got no light. So think of that kind of analogy for our irrigation system. If you have an open circuit, nothing's going to happen. Usually, the wire's been cut either from some other kind of construction. Sometimes critters, gophers like to get in there and chew on wires. And sometimes it could just be vandalism. Somebody decided to go out there and disconnect your valves because maybe they're getting wet and they don't want to get wet anymore.
Yeah. So this, right, open circuit, electricity is not completing the path, and you will not get water.
No water, Richard. And the important thing to remember, especially when you talk to when we're looking at some of our irrigation timers, a lot of times customers retrofit stations, so they'll remove a station but don't remove it from the programming, and the controller tries to water that station, activate that station, and it's saying, "Hey, there's nothing here," so it reports it open. Could be a valve got removed or disconnected, so they don't get any irrigation Either way you look at it, open circuit, you're not getting any watering out there. Could be because of cut wire, disconnected, broken wire. A couple of different reasons to cause that.
And so my controller is going to tell me you have an open circuit on zone 7.
Yeah, if you got ET Water Smart Controller, it definitely tell you every time it comes on. It tells it tests the circuit.
And if it didn't tell me, how would I figure this out eventually?
There's a couple tools that we can use. We'll touch on that. Um, they're helpful to do the open circuit. They're helpful to do a short circuit. For example, this short circuit, think of it as when you're driving, you're taking a shortcut. The electrical current decided to take a shortcut back to the controller and bypass your solenoid on your valve. Um, so short circuits could be a little trickier. It could just be a bad wire connection. Sometimes it's a corroded or bad solenoid as well. And depending on the severity of the short, your station may or may not come on.
Uh, so that's kind of key, right? Because the open circuit, I know it's not coming on. With a short circuit, I may be coming on, right? And I think an open circuit, if I don't get an alert, I'm going to find out because my landscape dies, right? Terrible situation. With a short circuit, it might be coming on, but it might be telling you, hey, check this out because tomorrow it might not come on.
Absolutely, Richard. Usually what you see with these irrigation shorts is they get progressively worse and worse and worse until the point where it just stops working.
So how lucky do you feel today?
Absolutely. And how long do you want to press your luck for?
Right, right. Because eventually you're going to have to fix that.
Correct.
Yeah.
And then our last one, Richard, is overcurrent. For this purposes here, as far as our alerts, it's basically pulling too much draw. It's too much work for the controller. Um, could be as simple as a bad wire connection, a corroded wire connection, maybe a defective solenoid. Sometimes customers like to put 2 or 3 zones on a station circuit because they ran out of zones for the controller. For example, they have 25 valves, but they only have a 24 station controller, so they put 2 together to get them work, and it causes the controller to work too much, too hard. Sometimes it could be simple as the wires have been cut and spliced and cut and spliced, and they have too many wire connections in there, and each wire connection adds resistance to that circuit.
So in that case, my valves are going to work or not?
Generally, they're not going to work, Richard. If you have a smart controller, it's smart enough to know that there's too much power going through there. In the case of our ET water controllers, it shuts off and protects itself. So we'll protect the controller and the watering stops. So, for example, say your controller waters a dozen stations and your station is going 1, 2, 3, 4, 5, and that station 5 has an overcurrent. Your controller powers off, suspends, sends an alert for overcurrent, and then your station 6 through 10, 6 through 12 would not have received any watering.
Oh, wow. So open circuit and overcurrent are big issues because
Absolutely.
water's not going to happen. And then with overcurrent, the other thing I wondered is that is it going to hurt the controller?
In this case, it will protect itself. I'll share a little story. We have a what we call an enterprise account, large private entity, and they had issues. The controllers were having failures, components fail. So they came to us and say, hey, our ET water controllers are having problems with it. What's going on? We're having computer boards get fried. There's a problem with your controller. And so we luckily controllers, we log all the data for these going on, and we come to find out, say, hey, look, your controller's been reporting these overcurrents for over 6 months. In some cases, 48 zones, watering multiple times. Say, hey, look, in the last 6 months, this controller's sent an overcurrent several hundred times. So it tried to protect itself, but it keeps trying. There's nothing else it can do. It finally failed. So most of the time, they'll try to protect
damage,
themselves.
right? The damage is through the expensive controller, not the less expensive solenoid on the valve.
So the nice thing, Richards, are smart controllers. We also have the reporting features, which is custom to each individual user. Each user is able to select how often, the frequency, if they want to get those alerts every day, and what we call our daily digest reports that you can see on the right of the screen there. All your issues for all your clocks are all on one email, which is very handy, especially if you're a property manager handling several properties with multiple controllers. I mean, we have some of our sites alone that have over 500 controllers, and just think of how many stations that is. It can be quite mind-boggling to look at that, but we can go through there, and you can just select which reports, which alerts you want to see on this report.
I see. So I can really be specific and say I only want to see all the controllers that have turf or something like that.
Yeah, use your filters in our reporting feed function, and you can look at that on the right. So if you see on the right, very right of the screen, the little plus or minus, these project numbers, and that's in each individual controller. And you see down below, you say like select which type of alert you want to look at, and then it'll pop up, tell you exactly which controller, which station, when it occurred, if it's reoccurring frequently. Simple to export these to a PDF format, so you can present this to your property owners or to your landscape contractors, so they can go out there and directly pinpoint and focus on those issues.
Wow. I would imagine that both the property managers and the contractors would be very appreciative of this type of a report. It's going to make their lives a lot easier, right?
Absolutely, it makes it very simple. And then the proactive alerts, when your contractor uh, opts into them and sees them, what I tell them is, "Hey, use this as a tool. You know, you're going to get your alert that you have a short today." Before your property manager calls you, say, "Hey, I got a problem," then you can tell them, "Hey, we're already on it. We got this alert overnight, and we're working on it. We'll have it resolved shortly. Here's what's going on." Really use this to your benefit.
Yeah, I think that's great, Danny. I know when I was at Valley Crest, we used to have a saying, and that was if we find the problem, we can bill for it. If the customer finds it and has to alert us to it, we're probably doing it for free.
No, I don't think anybody wants to work for free, Richard. So yes, definitely, that's a great way to look at it.
Yeah. Hey, I want to remind everybody for a second too that we do have the Q&A open. So if you've got some questions you want to ask, put them in there, and I'll ask them when it's appropriate. We did have a question already, though, Danny, that I wanted to run by you. And this question is from a viewer, and he wants to know the difference between a dead short and a short circuit. Is there a difference? What is, or is it the same terminology for the same problem?
Sure, would be a terminology for overcurrent. It's not going to water, and your short circuit may or may not water. Just depends on severity of the problem.
I see. Okay, great. That helps very much. Thank you. So when we have a problem with a valve, besides not watering, what other challenges can it present for our systems?
So we touched on the issue where it's could cause damage to the controller if it's not resolved promptly. Um, you're looking at increased damage for your stations. Sometimes it's a bad wire connection, could get worse and worse, and that could trickle down and cause issues with your solenoids themselves, overheating. There's a pintle inside the solenoid. If that freezes up inside there because it overheats, it could cause that valve to stick open, and then you got water running until somebody gets out there and shuts it off.
So, okay. And then I think too, Danny, do most of the wire problems or shorts occur right around the valve or sometimes other places?
So the majority of the time, when you come across is one improper parts to use. For example, wire connectors. We've probably all seen. I got one here, something like this little wire connector designed to be used indoors in your home inside an electrical box. Oftentimes we see that. If you recall back to one of the previous slides, and when the valve box was full of water, this would cause a short because water's It's going to ground that circuit directly, and it's going to get back to your controller, and then you're not having any water going through there. So we want to make sure we resolve these issues before they get out of hand.
Yeah. Okay. And so how do we find a short, or how do we find the problem? What are some tools? What are some ways we can do that?
So hopefully you got a E2R controller alerting you, telling you exactly which station's going on. If not, there's ways to do it using these tools. The number one tool on the left there is a multimeter, voltmeter. That is your number one tool if you're a sprinkler technician trying to resolve an electrical fault, or any electrical fault where you can use this in your home, on your auto, on your car. But that's the number one tool. So if you have a sprinkler tech that's going out and fixing sprinklers, you wouldn't send them out without a shovel. I wouldn't send an irrigation tech without a voltmeter. And then these other tools are pretty simple to use also. One that's very common is what's called a station master. It's a simple tool that just puts out 24 volts to your solenoid, and has these green and red indicator lights to tell you if it's a good, short, or open circuit. Real handy for testing solenoids.
And so that would indicate not necessarily, well, it would help you understand that your problem isn't a wire, but the solenoid in the valve.
Correct. So you can actually test this at the controller, which I'll show here in a couple slides. But if you have a solenoid that you want to put in, or it's at the valve, you can use this to activate the solenoid, and it'll tell you the quality of that solenoid, if it's a good, open, or short. You can also connect it to your timer on the terminals and activate the station, and it'll tell you if the control is putting out the 24 volts necessary to activate a station.
Wow,
But
very helpful.
ideally, what I like to recommend is the one on the right, the multimeter. If your contractor doesn't know how to use it, I'd love to come out and teach them how to use it. It'll make them more efficient at their job, and just help them understand all their power issues going off the clock, not just the circuit and a station, but the power coming in, testing their transformers to make sure those are working properly. And the one thing I want to make sure customers do, if you're going to use a voltmeter, especially on testing resistance on a solenoid, that's how we measure how much power, or the resistance is how much it's going to need to activate the station. Voltage times amps equals resistance is a formula. If we remember back to our high school days, you might remember that one. But the key thing is here, if you see on this meter, it has a little alligator clips attached to a solenoid. Oftentimes I'll see customers grab it with their hands, and that's giving them a false reading because it's testing resistance across your body circuit. So whenever you're testing any circuit for resistance, which is a little ohm signal, if you went to college, you'd probably say that's an omega signal. Either way, it looks like an upside down horseshoe. So remember, ohms is an upside down horseshoe, and you want to isolate it. So use alligator clips, or wind the solenoid leads onto the end of the tip of the connector. Don't be touching it when you're doing resistance testing.
Yeah, what a great tip, right? And yeah, it's interesting because normally I have the 2 points, right? The black and red points, and I touch the wires that way, and yeah, I don't get a good signal.
Absolutely. And so when you're testing a solenoid, you're going to hear different numbers of what a good solenoid is. I was always taught 10 to 100 ohms will work, and that's always worked for me. Some solenoids you can get down to 7-8 ohms, or a high as 120 150 ohms, and it'll still operate. A good rule of thumb for a solenoid is between 10 and 100 ohms. If your screen on there says OL, OFL, that stands for out of limits or out of field limits, or it's showing 0 ohms, that's an open circuit. It's not going to work. So it could be internally, or a broken wire within that shielding causing that issue.
Okay, and then if we're getting a short, we're going to see what?
And a short, generally, it's going to be over 100 ohms. If it's like a bad wire connector grounding to earth, or a nicked wire, very bad solenoid, you'll see what's we call kilo ohms or mega ohms. So like 1,000 for kilo or 1 million mega ohms, a million ohms if it's mega ohms. So it's important to look at your screen. If you see the one on the screen there, it says 32.3 and the little horseshoe ohms. If you see the little K before next to that last three, 32.3K, that's 32,000 ohms, real high resistance, and uppercase M for mega ohms. Definitely bad circuit. It's not going to work.
Yeah. So, Danny, one thing I always worry about when I'm messing around with electric or electricity is getting shocked. Now, I could probably figure out a way to shock myself with this. Can most people, though, shock themselves doing this testing?
When you're testing the with the multimeter, no, it's not gonna shock you. It's a very small amount of current that the meter puts out to test that resistance. If you're really concerned, you can let your smart controller do it testing for you.
Yeah. Nice, because yeah, that'll keep me a lot cleaner too.
Absolutely. This is where I would start at the controller before you go out and trying to find stations or valves in the field, especially when I go out in the field and they tell me, hey, I have a short, maybe I don't know, they don't know which one, they don't have a smart controller. I can test with the smart E2R controller, I can test it here, run through a diagnostics, or there's a way to test it from the controller and find that open circuit or short. But luckily, ET Water does it real simple. You can perform a raster test or test an individual station, and it's just a couple buttons to press.
So
So
I, yeah, so I just go to the display in the box on the property.
correct. So go to your controller. If you see that left image there, the little down triangle, the down arrow, you press that once and it'll pop up on a screen there. It says valve test, enter station, or it says all. If you go ahead and just press the enter button, it'll do a quick raster test of your stations.
Very
And
nice. So what does that mean, a raster test? What am I going to see?
So the raster test just does a really quick pulse test of that stations on your controller. You can see the zoomed in display down below. A controller will tell you if it's okay, short, or open. In our case, OP for open, SH for short circuit, or OK for good. And your controller, instead of testing ohms like we did with the meter, is testing milliamps, which is the current draw through that circuit.
So this person's got a challenge, right? Because their master valve and 5 of their 6 valves is open.
So in this case, what I would do for troubleshooting, if it was 6 stations and they went down the line in sequence, I would say, hey, up to station 1, I'm okay. And most likely my common circuit's going to be my issue because I have multiple valves that are open. Normally, a good circuit would be somewhere between 250 and 350 milliamps.
Yeah. So, okay, yeah, because it would be unusual to have this situation on the screen. So again, probably the common.
Correct. Yeah, you're having 1 or 2 shorts here and there, maybe an open if there's a station missing or a cut wire. But if you're seeing them all open, then you got a bigger problem. But usually just one common circuit issue affecting all of them, because all the circuits, all your station wires share one common wire, which is our ground circuit, and then they each get an individual station wire.
So, Danny, we've got another question coming in, and this person's wondering, can we do a raster test remotely, or do we actually have to be at the controller to do it?
The raster test does need to be done remotely. You can test stations individually remotely. So using your Unity mobile app, you can do basically what we're doing here on a single station by activating a station, doing a check status. And what that does is one, you're activating the station, you turn the station on, and then the check status will ask the controller, hey, what's going on? And reports back, hey, I'm watering this station. If you have a flow sensor, it'll give you the gallons running, and it'll tell you the milliamps draw for not only the master valve, but the station you're testing.
Wow, a lot of information available without being at the controller.
Correct. Yeah, I would do that before sending a truck out for sure.
Yeah. Great. Thank you.
And then you can do a single station test and look at the individual milliamps readings for that for the stations. Just real quick, down arrow again. Key in the station you want to test, and then press the enter button. It'll run the station. It'll activate it and tell you the milliamps for that individual station.
Very, very nice.
So if your controllers say your diagnostics function is not working or any other standard controller, you can do it with your multimeter. Um, Very simple. So all your controls have a common. Most cases or standards using the white wire for the common to identify it. A lot of residential controllers will have what we call the multi-strand wire. So all the other station wires will be a different color. Um, and the commercial applications generally try to use a red wire or for the station wires, but they're all the same color red. And the common wire, normally white, sometimes black, sometimes they use a different color just because that's what the distributor house had on hand. But a general rule, your common's white, your station wires are either colored or red. And doing that station agnostics, so like we tested for your solenoid individually with the wire little alligator clips. If you put your common terminal on the black and your station terminal with the red lead off your meter, you can test your milliamps from here. So I would start here at the controller if you're doing a manual check. Check for your milliamps again. I'm sorry, test for your ohms. Put in that in resistance in the little horseshoe symbol there. And again, between 10 and 100 ohms would be a good circuit. If this reads high, then I would go down the line to that station that you're looking at, disconnect from the wires, do a solenoid test, and test if that solenoid is good or bad. If that solenoid is good, then you got a bigger problem.
Right. Right. Hey, Danny, does it matter if I put the red on the common and the black on the station? Is that an issue?
No, not for this test. Resistance just testing the circuit. Where that would be an issue if you have red or black switch, issue would be if you're testing, for example, like a battery or a DC system, a direct current system. You'll still get a reading. If you got them backwards, you'll just get a negative reading. So if you had a 24-volt system and you put it backwards, say, hey, you got negative 24 volts.
Right. Okay. That'll be my clue, the negative.
Yes. So, like I mentioned, if you went down the line, your solenoid was good and it tested fine, it tested bad at the controller, you got a bigger problem. You're gonna have to break out the bigger tools and do some serious troubleshooting. These are some of the devices that are available. What we call a wire locating or wire tracing tools. Just kind of depends on which one you use.
Yeah, I was
So
going to say I'm going to be very sad, right, to have to find a broken wire now. A clue might be, gee, I was putting a plant in this area the other day. Did I go through an irrigation wire? I mean, that'd be some of the things, but I think in general, most of the breaks are going to be pretty close to the valve, right?
in general, mostly by the valve. You touch on a very important thing there, Richard. Whenever I've gone out to do troubleshooting, ask questions. What kind of work have you done? Right? We had the gardener digging around. Well, my spectrum timer's right next to it. My valve's on the other side of my planter. Maybe they hit a wire, right? Oftentimes it's a different trade, right? The poor concrete guys came in, they excavated a little, and 9 times out of 10, they're not going to tell you if they hit a wire. So then you're stuck trying to locate those wires buried below ground, and these are some of the tools available. What I do highly recommend is using a quality wire tracer. My go-to is the one in the middle there. It's a buried line locator made by Greenlee Tempo. The one on the left is kind of your industry standard 570 or 720 detector. Takes a little bit longer. Highly recommend going with a better tool for this type of job here.
Yeah, that one
And
on the left, it looks like I could maybe find some coins or some a ring with it.
pretty close. Yeah, absolutely. Nice thing about the higher end one, you just push a button, it'll tell you the depth, so you know how far down you have to dig that wire. Once you find that wire break, you know how deep. It'll tell you, hey, it's 1.2 feet deep. So you know how far to dig down before you start hitting more wires, right? Start
Yeah.
slowing down. Um, so
That's pretty cool. That's worth a lot, right? To know that distance.
definitely, definitely, especially since a lot of times your main line and your sprinkler wires were installed in the same trench. You don't want to drive a shovel through that pipe and then you're fixing a broken pipe and a irrigation wires.
Yeah, sounds like a bad day.
Yeah. So, Richard, a couple things I'd highly recommend in using when you're troubleshooting and doing repairs. One, your multimeter. Like I said, you're not going to send your sprinkler guy out there without a shovel. This is your number one tool if you're a sprinkler technician that's repairing irrigation, uh, testing valves. I don't know how many times I've gone out there and the customer tells me, "Hey, I had a short." Well, how did you fix it? Is what I asked. Well, I just tried another solenoid. Well, did you really troubleshoot it? Did you diagnose it? You know, some of these valves nowadays can get kind of pricey. A lot easier to just actually do the troubleshooting, and then before you open that up, then you got to shut your water off. You got water running. You might be getting wet. Test the solenoid with your meter. Save yourself some time. And then Hydro Rain, we make a very high quality wires connector. So if you recall these little ones I showed you indoors, try to stay away from those in a box, especially if below ground. They're not rated for below ground use. Use something with a nice waterproof connector. If you see that, you can see that little window on the bag. They have a silicone sealant in there. So even if your valve box fills up with water, your wire connection is still protected and it's not going to ground to earth. And
Very
lastly, keep
nice.
those valve boxes clean, easier to work on, easier to test in the future.
Yeah. So those valves look kind of cool with the nuts on them. You can just spin those in and out.
Absolutely. So shut your water off. Are you talking about the unions on the side to replace?
Yeah.
Yeah, absolutely. So those are nice orbit valves with the union on there. No need to cut or re-glue pipe. You just spin those union nuts off and swap it out a new one with the new valve. Replace the old damaged one. Um, Tighten those back up, and you're back up and running. No waiting for PVC cement to set up.
Yeah. I can't imagine how much time that saved you. That's fantastic.
Yeah, especially if you have a high pressure system. If you're in a cold weather area, or sometimes you might need to shut this water off for 24 more hours to allow that cement to cure properly.
Yeah. Very nice.
Lastly, Richard, I do have one tip. If you have a circuit has just too high of resistance, if you look at a lot of installation specs now, you see on the top left there says a 30-inch linear length of wire oiled up. One, remove any unnecessary wire nuts. I don't know how many times I come across a valve. We open it up and there's 7 wire nuts because the last tech cut it, added on, the last one cut another one. Eliminate all those extra wire nuts. Each wire nut connection adds resistance to your line. But if you have a circuit that's just so close to activating the station, coil up a piece of wire like that, creates a little magnetic induction, helps pull that current through the wire. It might help you get a station activate when it wasn't going on.
Wow, that's really a good tip. I hadn't thought about that before, but wow, that'll be a troubleshooting time saver for me, Danny. Thank you.
You're welcome.
So, Danny, how can if people have additional questions? I mean, this was a ton of information, very helpful today. But if we have more questions or need to get a hold of you, how do we do that?
Yeah, absolutely. Feel free to reach out to our customer care or anybody within our department that will gladly connect you to me. If you need further training for your technicians or landscapers, we'd love to help you guys out. Um, but just go to our website and we'll get you connected to the right person.
Yeah, that's great. And if you just also respond to the email invitation that got you here, that's another way to get a hold of Danny or me.
Absolutely. Thank you, Richard.
Oh, thank you, Danny. This was great today. I learned a lot, and I'm not going to say I'm looking forward to my next alert on my controller, but I certainly know when it happens because it eventually does. I'm going to be more prepared, better prepared to fix it in a quick period of time. And man, these days we're all dealing with time issues, right? And we all have the same amount of time. It's just how you use it. And this is going to help you use time more efficiently. So thanks so much to all of you viewing today. Thank you for your time. We really appreciate that. Remember, you can go to hydrarain.com and see all of our webinars there, and you can view them for free. They're always free. We also take the audio out of these, and you can go to Spotify or wherever you get your podcasts and listen to these. You know, it really gets me excited, Danny, to think that people are out there maybe working and educating at the same time. What a really good use of time. Again, that we're so smart about managing. That's really great. So anyway, thank you, Danny. Thanks everybody for joining today. And we'll catch you guys back here in a couple weeks. Thank you.